So finally it's time for us to work on our Hexapod rigs, and there are two assets, so we'll be building two rigs actually. This one here was kindly provided by Edwin, Houdini Artists, and I will ship this as it is. The other one you can get for free. I will leave the link in the description and in the zip file as well. This is my working zip file, but you get everything again except the skeleton setup, but the apex part will be in the zip file. So you may think that since it has been 16 videos just for kind of a simple piston rig, maybe you may think that, well, for this that seems far more complex, this will take forever. And that couldn't be far from the truth, because it's Houdini. That's why I've been laying the foundation, and both in terms of knowledge and automation, using this kind of Apex for building Apex graphs. And in a nutshell, this will take only 3 videos. So before we take a look at the guide skeleton and in general the skeleton, let's first go back to Miro and draw a little bit to understand what I'm aiming for in terms of the logic and therefore the guide skeleton that we will be using to drive the rig. So here we have the second model. So Edwin, sorry about that, but I'm using this one for drawing because it has simpler geometry, so I think it's easier for me to show. And each colored part is in the rig will become a single packed geometry piece. So this one will be the base. This is fixed. So the base is fixed and will be driven by just our root X form. And this tiny part here I called cross. So this one will be the bottom cross, and this one here will be the top cross. And this part in green here is the bottom piston, and this is the top piston. And that part on top will be our top part. And here is where we will animate our rig. So here, as I just said, is the part where we will animate a rig. We can, of course, use the root transformer to reposition it and maybe even scale it. So that's the general idea. And before we talk about the rig, we must inspect our geometry. So we'll be able to create some hypotheses about how this works. And of course, as always, taking a look at some references will be a must. But since I've already done that, I won't be doing this, but take a look at YouTube and search for Hexapod. You see a lot of those things, not just in 3D, but in reality as well. This can be built. So since this part here is fixed, this bottom cross here, it will rotate along this axis. So it has just only one level of freedom. because it can rotate just only on one axis, and it's fixed in any other axis. And this bottom piston part, it will rotate only along this axis here. So I hope it makes sense. If we take a look at this one, maybe it's easier to see. So we have this axis here, and it can rotate only on this. And the same for the top part, just reversed. So looking at this way, the idea is pretty simple. So how do we do that? So for this bottom cross here, since we want it to be fixed in the main axis and just rotate on the second axis, the idea is to create this as its main axis. So this will be its z-axis, and the other axis will be perpendicular to this one. So it will be something like this. And you may ask, why not something like this? That's because each axis must be perpendicular, but since the lookout constraints have a clever logic, we can point out to this joint here, and it will end up creating this vector here perpendicular to this one. And for the bottom piston, since it will rotate along this axis here, the idea is to make this as the primary axis, and here we will have the secondary axis will be our y-axis, here our y-axis as well. So the same for the top part. So let's take just a quick look, but the idea is the same. So let me draw maybe for this one. So this will be our main axis, and then we will have another one. Take a look at this. This is box shaped. So let me draw here. And then the secondary axis, the axis that will rotate this primary one, will be something like this. That will rotate along this. So that's the idea. And again, for the top piston, we'll have, let me change the color here. We have this as our primary axis, and since we want to rotate along it, the secondary axis will be here. So in terms of joints, for the bottom cross, we need a joint somewhere in this direction. So let me change the color, maybe this, yeah. We need a joint here to be used as the lookout. And for the lookout up, we can use the joint here, because again, since the lookout constraint has a clever logic, even if this joint here is not perpendicular to this one, this axis here will be created using the best approach, something like, it'll be used something like this, a plane. So it will be pointed to this plane here. If I'm not mistaken, it'll be something like this. And then we can use this as, let me call this one bottom cross look at. And this here will be our bottom cross look at up. So these two joints will be used for creating this orientation for this bottom cross. And since this top piston is attached to this cross, this bottom cross here, this piston should be parented to this bottom cross. So when this bottom cross rotates, it will rotate the bottom piston as well. The same for the top cross. When it rotates, it must rotate this top piston as well. Therefore, this top piston should be a child of the top cross, and this bottom cross here should be a child of this bottom cross. And for controlling the look at for this bottom piston here, let me remove this. Since this will be rotating along this axis, we must have a joint in this location. So this will be, since this is our main axis, this will be our bottom piston. Look at. And since this joint here, it must rotate along with this bottom cross. So you can imagine that since this bottom cross here is rotating side here, if it rotates, this will be rotated as well. So this here should be a child of our bottom cross as well. And for the up vector, we can build using this joint here. So this should be our bottom piston. Look at up. And this should be parented. This won't make a difference if it's parented to the bottom cross or the top part, because the bottom cross only rotates. So this will be sticked in terms of word position. So, but in the end, we'll be parenting this to this base part here. Actually, we'll have a joint here, so we'll parent it to this joint. So I hope that makes sense, this idea. And maybe this can give you a clue about what I was telling. This is our main axis for our bottom cross. Take a look here. Are these parts. So this will be our main axis, and this is our secondary axis, our y-axis. But we will create this, or at least what will drive the secondary axis is this joint here. But since the look at constraint will build it using its clever logic, it won't be pointed here, it will remain perpendicular. So again, here is what I just said. And that's it for the general idea. So we will need for this bottom cross one joint for its main axis and one for the secondary axis. So two extra joints. The same for the bottom piston, and the same for the top cross and top piston. And I can't remember exactly if I talked about this, but since I'll be using the same logic that we talked about earlier, using this pattern, to run the rig logic on groups of transformer objects. That's why I'll be creating extra joints for each group instead of trying to reuse the same joint for different purpose, because we are using just a single array for everything for the tags, and things will start to get messy because it'll be harder for us to build or to change the logic inside the loop. Of course, you can take a look again at this guy here. Let me actually it's not this one. So the issue is here because when we are trying to find these intersections of the tags, if we are using the same tag for different purpose, this will become a mess, of course. You can try to figure out this. Maybe you will be able to find a solution and use fewer joints that I using currently. So that's the general idea. And this is the file that you will be receiving. So here is Edwin's the geometry that he provided. Here is after I repositioned it, and for this I haven't changed the orientation, just repositioned, created groups, and packed geometries as well. Here is the base skeleton, here is our guide skeleton, the same for the other rig. This is already packed and everything else. And here, of course, the source of the geometry if you want to get the original file. So this is our kickstart for this piston, for this hexapod. And in the next video, we'll take a look on the guide skeleton. That is for us now the main thing that will be used by our Apex script to not only create the transform objects, but to drive the logic of the rig as well. But you may see here something that I talked about a bit earlier. So that's it for this video. And again, the next we'll take a look on our guide skeleton for both rigs.